which include establishment of supercomputing facilities and the ecosystem development in the country, and development of critical HPC technologies like computer servers, high-speed HPC interconnect, and system software stack. And as was mentioned earlier, also, he and his team have received the Dr. APJ Abdul Kalam HPC Award for their contribution to the supercomputing ecosystem in the country. Our next speaker, Shri S.R. Krishna. So if I, it's difficult to recognize people with the mask also. Shri S.R. Krishna, Director APJ HPC and AI Intel, a very well-known technocrat with experience starting from R&D to being responsible for the APJ HPC business at Intel. He's fondly, and many of you know, he's called as Mr. Sita, and he's currently leading Intel's HPC and AI business. Currently, he's supporting all strategic Exascale and large-scale HPC and AI projects in the APJ region, covering APAC, India, ANZ, and Japan. Mr. Sita has been recognized with several awards for his contributions, which he has made towards the promotion of HPC in his long 35 years career spanning from the Department of Space, CDAC, Tata Group, and presently with Intel. He has led the team developing ICA, fourth ranked supercomputer in the world at Tata CRL, making India proud in 2007, and created cloud HPC services first in the world in 2008, serving global users. Few awards which he has been conferred with the Param Awards from CDAC, JRD, Tata Innovation Award at Tata CRL, APJ Award, APJ Abdul Kalam Award for HPC, and then several divisional recognitions from Intel. Our next speaker is Dr. Hemant Darbari, ex-DG CDAC, and alumnus of IIT Roorkee. He's one of the founding members of CDAC and our institute set up by the Department of Electronics and Information Technology. Dr. Hemant Darbari, as the former Director General of CDAC, led a pool of highly specialized scientific R&D, technical and administrative personnel with his broad scientific R&D and technological vision. Dr. Darbari was conferred with the Vishwa Hindi Samman at the hands of the Honorable Minister for External Affairs, the then Honorable Minister of External Affairs, Srimati Sushma Swaraj, for for the contribution of CDAC in the field of Hindi language, computing, research and development, proliferation of various deployments at the national and international level during the 11th WHC on 20th August 2018. And now I invite our moderator of the session, Colonel A.K. Nath, retired Director General and Executive Director, CDAC Pune, and alumnus of National Defense Academy, Kharagwasla, and India Military Academy, Dehradun. Colonel Nath joined CDAC in July 2010 as the Executive Director of CDAC Kolkata, and after 25 years of experience in the Indian Army Corps of Signals, which deals with communications and IT, he then joined CDAC. Under his able leadership, CDAC has bagged various awards and projects at the national and international level. So with all our eminent speakers here, I would like to hand over to our moderator, Colonel Nath, for the proceedings of the session.
Good afternoon, everybody, and welcome for the post-lunch session. And to excite all of you, I think we have a wonderful panel with great and a very diversified experience, I would say. And I'm sure they would be time worth it while you're here. And we would expect some good interaction by way of question answers after they have spoken, which would make the session even more interesting and interactive. So I invite now Shri Sanjay Wandekar to talk about the background and journey of NSM
Thank you, sir. Presentation, please. So, so thank you for inviting me here for giving brief about National Supercomputing Mission. In the morning session, I gave some little brief. I'll be detailing out what are the activities we have done under this mission. So as I told you earlier, this National Supercomputing Mission is driven by MIT and DST, both ministries, and is going to be is basically a very large program of rupees 4,500 crore over the period of 7 to 8 years, and this is being implemented by CDAC and ISC together. So there are four major activities or objectives of this mission. One is developing the supercomputing infrastructure in the country, where we are actually deploying various capacities of systems over the country, and developing the indigenous supercomputing ecosystem in a phased manner, where we started with assembling of the various components and subsystems of the supercomputers, along with the software stack. And then next stage was to manufacturing of the subsystems within the country. And third step is basically designing and manufacturing of the supercomputers. So in this journey, we started developing various technologies which are required for supercomputers. So basic building blocks of supercomputers are mainly the servers, HPC interconnect, then software stack, and basically the processor technology. And now, because of very high power consumption, you need liquid cooling technologies also, which are very important because of high power requirement. The third major objective of this mission is basically developing the supercomputing applications of national interest. And fourth pillar is basically human resources which are required for supercomputing applications as well as running this kind of facilities. So these are the four major objectives of NSM. So I'll take up first the NSM supercomputing infrastructure. So as I told you, we are doing this in phase manner, phase one, phase two, phase three. And under phase one, we did the assembly of the systems and with the indigenous software stack. Phase two, we manufactured the subsystems within the country. Phase three, we are designing and manufacturing the complete system within the country. So till date, about 15 systems with compute power of about 22 petaflop has been set up within the country at various IITs, CDAC, NITs, JNCSR, ISCs, ICERs. And these systems are already being used by users, and about 28 lakhs HPC jobs are being done on these systems. And these systems are being used by about 2,200 users across the country from 85 plus institutions. And phase three, basically these are going to be larger systems, and this will be completely indigenous systems. So as I told you, I think there's some shift in the slide. The last one is basically about 40 petaflop of compute power is basically getting established under phase three of this mission. So these are some systems which are already established at various places. I'll just quickly go through them. About 9 of them are already commissioned, and remaining 6 of them are getting commissioned shortly, maybe in another 2-3 months' time. We have built the system, but commissioning is currently on. So this is one of the system which is basically for both HPC and AI purposes. So we call it Param Siddhi AI. This is a national facility which is being established, and people across the country can utilize this. So this is a fastest supercomputer within the country, and it ranked 62nd position in the top 500 supercomputing list in November 2020. Uh, and about 139 users from 19 institutions are currently using. It's a recently commissioned system. So this system, as I told you, it is mainly for both HPC and AI applications. And for in the AI also, it is mainly made for training the AI models using very large data sets. So once these data sets are basically the models are trained, then that can be actually put up on various data centers for inference purposes as well as on the edge devices. So that is the main purpose. And there are various domains, applications are being used on this system. And we are planning to open up this system for even industry, startups and MSMEs, and this at a discounted rate compared to the what is available commercially from cloud providers. So on this system, we have put various tools which are mainly basically for visualizations, then various libraries for development, and then tools for programming models like MPI, OpenMP, and so on. Apart from that, we have put various applications which are commonly used on these HP systems. So these are optimized applications which are for the specific architecture on these systems. So there are various domains like bioinformatics, molecular dynamics, material modeling, quantum chemistry, CFD, and weather and disaster management. So many applications are there, and the users can start using the system from day one onwards. Okay. So they don't have to get their applications and program and all those things. They no need of compiling and struggle with the programs. Apart from that, all the systems are having AI, ML, DL tools and technologies, mainly the frameworks, DL frameworks like TensorFlow and CUDN and PyTorch, and so many things. Data science frameworks are also there. Then there are some IDEs also which people can use for DL applications. So all these systems are basically having various tools to monitor the various resources and users. So this is one typical system utilization graph, which is generated by the tool developed by us, which collects the information, and it basically gives some kind of input to the management or the policymakers at how the system is getting utilized and what kind of applications are basically using the systems and which applications require more number of cores or what kind of architecture they are using, and so on. So this particular system is being used by computational physics people, like more than 30% people are 30% computer power is being used by computational physics. So now I'll talk about what are the various indigenous technologies which are developed under this program and which will be utilized in phase 3 of this mission. So major indigenous technologies which are developed is one is Rudra server platform. Today is getting launched, and you would have seen in our stall also we have put this server which is developed under this program. Then HPC interconnect. This is again one important component in any supercomputers, which basically connects multiple computers or servers together at very high speed network. Then HPC system software stack. This is what is required to put all this together and show as a single machine. Then liquid cooling technologies, as well as as morning I gave a talk on OHM HPC processor also, that is also getting developed. So this is a Rudra server platform, what we have developed. Mainly This is based on Intel processor and is very high dense form factor server, which has two form factors. One is half width 1U and other one is half width 2U. Okay, so in one rack, one can put up to 64 such servers with 40 kilowatts of power consumption. It supports two GPUs, and this is targeted for both HPC and cloud market. And it can be customized for various other requirements. So we have benchmarked this, and we have a small system running on this servers from last 3 months, and it's getting continuously used by the users. We have run some benchmarks of HPC. You can see here the 4 benchmarks which are there in various domains. And we have compared with the industry standard server which are available in the market. And we are doing better in many cases, even though our processor is running at 2.4 gigahertz and the industry server is running at 2.9 gigahertz. So you can see in some of the places we are doing much better, even though we are having slower gigahertz. Again, we have run some benchmarks which are cloud related also, ResNet and TPCC benchmarks, and we are able to get the on par performance with the cloud providers. So this is a server roadmap. So currently we are at Rudra 1, which is based on Cascade Lake, and next generation Rudra 2, which is based on Intel Sapphire Rapid, is getting developed, and it is we have started already that, and we expect that by June 22 we'll be having the Rudra 2 server, which is going to be Sapphire Rapid basis processor, which will support 4 GPUs, and this can be utilized for both HPC and AI systems. And we are targeting about other markets also, as hyperscale data centers and cloud and storage also for this. And third, Rudra 3 is basically Ananta server, morning I talked about, which will be based on CDAC's OM processor, which again will have GPU support, and we are targeting the same market here. So this is current roadmap related to Rudra 1. We are actually going to put the 32 petaF of compute power based on Rudra 1 and partially on Rudra 2. And requirement of around 5,000 servers is there, and we are in the process of shortlisting EMS vendor for manufacturing this server, 5,000 servers. And then we are looking forward to industry collaboration. We are already in the collaboration for development purposes. Then next thing we are looking for technology transfer to OEMs and ODMs, as well as I told you that manufacturing and support. So next technology what we have developed is Trinetra, which is a HPC interconnect. Basically, this is a low latency, high bandwidth, and scalable network. So this kind of networks requires very large, they should scale to very large number of nodes. We need to connect with a very low latency across the nodes. So this particular network is developed for scalability purposes.
Got to hurry up.
And I'll do that. And we have actually 2 versions. One is 100 gigabit, other one is 200 gigabit. It supports cascaded hypercube topology. This is a software stack we have developed. I'll just skip this. Then this also I'll skip because we already discussed about HPC processor development. We have developing again the cooling technologies where there's a chip cooler which is sits on the CPU, and there is a 30 kilowatt panel water heat exchanger which goes outside. So with this at 35-degree temperature, one can with water it can cool the chips, and which basically will have very good efficiency of cooling. Currently, about 50% of the energy goes in the cooling, so this will actually reduce it to 5%. So there is a lot of saving in the energy here. So we are working with various collaborators, as I told you. Our technology partners are Intel, Mellanox, NVIDIA, DDN, and phase one, phase two manufacturing OEMs is Vatas. Data center, there are many OEMs. Again, as I told you, we are doing developments with the industry partners, QWave, Sienna, Coral, and we are looking forward to EMS partners, and as I told you, home processor also we are working with the industry. So under NSM HR activities, we have already trained more than 11,000 students, researchers, and faculties through faculty development programs, online courses, workshops, boot camps, and again, we have set up 4 nodal centers at IITs, and all these IITs are actually conducting various online courses. And our mission is to have 20,000 HPC trained manpower. So under application program, I think the next session, next speaker was actually application related things. So he is not there. So I'm just talking on behalf of him. So there are 4 major applications I'll discuss here. One is early warning flood prediction for river basins of India. Under this, we are developing a full package for flood prediction. And we are working with CWC here and other states, other Odisha State Disaster Management Authority. So we have already set up a model and for Mahanadi River Basin, and we give 3 days forecast for Mahanadi Delta region using NSM systems. So output of this daily simulation is given to CWC.
I think Sanjay, we need to wind up. Yeah. Those are 2 other speakers, so you can finish now.
So this is the details of that. And this is another application which is seismic imaging to aid oil and gas exploration. We are working with ONGC on this, and this is a package which is getting developed based on this. Third application is NSM Urban Modeling Project, where we are working on a decision support system and giving the forecasting system for extreme weather, flash floods, and air quality pollution for the cities. So we are working on with various cities like Pune, Delhi, Bangalore, and various users are there, Urban Disaster Management Agency, Municipal Corporation, and so on. So this is overall thing, how the users are utilizing this, going to use these services. And this is the 4th application we are seeing. Basically, the NSM platform for genomics and drug discovery, which basically gives the platform for the users to develop applications in the bioinformatics. So there are 2 major things which are going to be available in this drug discovery pipeline, so that all the tools which are required for this are basically developed under this, and this will be available for the users. As well as we have a genomics pipeline where these tools can be utilized for early disease detection and personalized health care. So this is the outcome of summary. I think I'll just skip this because I already talked about this. And this is what is the overall summary, where we are developing the complete supercomputing ecosystem, indigenous ecosystem. Then various beneficiaries are there. We are working with the industry, and we feel that this will catalyze the high-end electronics and manufacturing design capabilities in the country. And we have seen that many people are coming for manufacturing within the country because of this program. And there are various byproducts which are going to come out, and various applications are getting developed. So thank you very much.
Thank you, Sanjay, for a illuminating talk on National Supercomputing Mission. So now, after a deep dive in the macro, we would like to now get into the micro aspects. And I invite the microprocessor man, Shri Sitaram, Director, Intel, to talk about accelerating indigenous supercomputing.
Thank you, mighty CDAC, for inviting us to be part of this Atmanirbhar program in the country. And I move quickly. It's expected that 2 ministries going to come. we need to pave way for that. Friends, the topic is accelerating indigenous supercomputing. Intel has been for the last 40 years into the microprocessor development and then the tools and then the engineering, the designs for it. So across the globe, Intel has been participating in its indigenous HPC programs, either you call Europe, US, Japan, Korea, and now India for the last 5 years. We have been engaged with MIT and CDAC closely to develop the indigenous HPC here. Yeah, this is one contribution I thought, quite notable apart from deviating from Intel's hardware oriented or the tools oriented or the core technology kind of a thing. So when the COVID hit across the globe, all of us suffered it. What Intel has done is that Intel has funded and then in manpower, in making the applications, in making the solutions together across the world, around 230 projects that we have funded. And the core contribution is that we work with the NAMD, the code developers, and then we have enhanced the speed of that on any technology of Intel, whether it is 3 generations behind, 2 generations behind, or the current generation, it will work 2.4x speeder. That means you don't need to invest 2.5 times to get that speed. On your existing technology itself, you get a 2.4x. That way that we have contributed to the world indirectly that 2.4 times the money has given back to the governments and then the labs so that they can deploy money for the overall attacking the COVID aspect there. So this is the core effort that's gone across the 230 labs across the globe. Friends and then the colleagues and then the co-colleagues here and then my industry friends here, Intel believes strongly that the performance has to go up because the demands of the world in high performance computing are increasing. As all of us know that the data is increasing because of the data that now big data, either AI and then the supercomputing, they are all combining, the barriers are closing there. And because of those barriers are closing, earlier we used to handle only computing side, now AI and then the big data also need to be handled in the systems and then in the process. So the performance is getting not 3x, 30x kind of an importance, or that's the kind of a demand that's coming up. Apart from that, no one single organization can provide these requirements to be fulfilled by the industry or R&D or government kind of a thing. So unless until we don't make open the technologies or the standards, it's very difficult. So believe in making the open standards and then the scale. So Intel has its own plans and then it's been working onto it. But because of the pandemic, that we saw that there is 30, 40x demand has increased and then across the globe that we are finding shortage of silicon. And now we have opened up that we co-work with other fabs also in the world, our competitors, and then we scale up the requirements. Friends, solving the workload, just to give a complexity that's going to come up. Today, scalar, vector, matrix, and then the spatial workloads, they have been independently working or at max into one system kind of a thing. The tomorrow, might all of them combine into one system or one CPU or under one package, 4 of them will be coming. There is some kind of a semi-tight coupled integration need to happen. The softwares need to be developed, applications to be modified towards that. And then the future is going to be like, under one chip, you will have all kinds of accelerators. That's where my title also is accelerator here. So you will have, all accelerators very tightly coupled, both with firmware and then the hardware, and multiple process technology getting integrated. Without that, we cannot face the requirements of the end user. So this is what we expect the future is going to be there. On top of it, the demand is that everybody wants single hardware, which is programmable for the requirements of the every domain computing purposes. So there is a programmability, tighter integration, and then the scalar vector, and then the matrix and then the spatial integrations need to happen in this. So the complexities are becoming really 100x, and those are the challenges that we need to face. Towards that first step, that Intel has already started experimenting the core CPU. There are going to be throughput cores, and then there are going to be performance cores from the Sapphire Rapids onwards. And then the open interfaces like PCIe-based CA, that's an interface that's getting open for industry. Gen 5 is the introduction, and then if you come onto this thing that there are multi-package technologies that are making open by Intel, EMIB and then multi-tile. And we are also working with other industries to adopt these things. And as I said, that accelerators are going to be the reality in the world. morning also, one of the panelists spoke about, there are domain-specific processors coming up, and the era of one general purpose is going to be difficult to sustain kind of a thing. So with the Sapphire Rapids, which is upcoming, which collaborated with CDAC to develop a server here, so that has multiple accelerators in that. Apart from that, the multiprocessing or the AI or the visualization. So we have seen the demand that's coming up from the gaming industry. And when it comes to AI, there is a requirement for DL kind of processing powers. So Intel has introduced its XC series of GPUs. And from second half onwards, the XC series of GPUs would be available to the market. And we expect that it will be on par or ahead of the industry available competitors from the market. So this one combines with its CPU plus GPU, and in future, maybe all of them getting integrated into one either platform or into one chip kind of a things. As you have seen that there will be three modules that will be coming up. One module, one single Ponte Vecchio, and then four modules, which is going to come out as a one large board where these four modules of Ponte Vecchio will sit, and then one server card will be sitting four GPUs and then two Sapphire Rapid CPUs with CXL. CXL is a a cache coherent interface. There one can add any accelerator, and it's unlike PCIe. You don't need to go through the IO protocol. You can go through the same memory to memory IO map and then reduce a lot of gaps arriving at the data copying and other these things. Yes, we talked about the processor, what investments going on by Intel. Then we come on to the open platforms. As you are aware, from Ethernet to today's CXL, there are several technologies which are being industry standardized, and many more are going to come. Without that, opening up these things, it's very difficult to meet the expectations. And towards this opening up and then getting integrated, multiple technologies. Today we have seen that I develop more accelerators. I grown up in CDAC, developing multiple accelerators by CDAC in those days, graphics accelerators, signal processing accelerators, vector accelerators, and many of them. And then there is a ton of engineers required to develop softwares and libraries and then the applications and all these things. So because of that, the accelerator technology has got limited to very niche kind of applications, but it could not scale up to the CPU level of these things because you need multiple programmers, multiple industry standards to be followed up there. Now, at a hardware level, yes, Intel is putting up and then it's joining the industry to develop open and standards in the hardware level. And the same thing has to be reciprocated at the hardware level. So what we are doing is that we have developed a one API standards, which is made open. It's an industry consortium-based one API standards. And we are seeing that a lot of industries have already joined to utilize this one API. It is a vision that's going to continue further and further, invested by government, invested by Intel, and then the open source community and other industry partners here to make one source run everywhere kind of a things. So that is the one that which will further reduce the pressure on the application developers. Now coming back to the country, what are we doing? Accelerating Indian supercomputing plans. Yes, this is the most important thing. We started our journey with CDAC, and I'll come to that. Before that, Intel has invested in all these core areas as an R&D center with 10,000 plus engineers working on together here. The money that's gone into this is more like $5 to $6 billion into this. Whatever the work that you say that Intel has been working on in the US, there are peripheral works or some of the core works are happening here from design, enabling, and then the ecosystem development in this particular lab here. The Maker Lab in the bottommost one, you see it here. The Maker Lab is the one that you develop a hardware, you come to Intel and work here. We bring in the world standards and then world qualifications will help you to get there. So ecosystem, that's a major thing that that we are able to do it. And apart from the HPC, several areas that with industry we are working from desktop to 5G, 4G, technologies into the country as part of indigenous development. And this is what the things that are invested by Intel already. Coming on to NSM, thanks. We've been participating with, thanks to the country, Prime Minister, to everybody that this country has got the funding, and then we got into supercomputing race again, and indigenous supercomputing, very interesting this here. And we have seen Sanjay talking about NSM, and there, we are lucky to get participate along with CDAC here. and part of the Rudra server development, where 3 years back, 2.5 years back, we been started our co-journey in working with CDAC on this, and today we are seeing the fruits of that. That indigenous server, very technically strong, highly complex server, 2U4 node high dense, which is you know any ODM or OEM also. Really speaking, that to my knowledge, I will not reveal how many engineers have worked to develop this from CDAC, but very, 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 very minimal engineers have worked. If the same thing industry has to develop it, 10x more engineers need to work to come up to the speed. I'm thankful CDAC could work, last several years, day and night, and then reached out to this. Of course, there are testing points now. After everything has come, there is a silicon shortage across the globe. I'm sure, I wish, I pray God that we also cross through these shortages, and then get the next generation Sapphire Rapids designs getting ready, and then CDAC would succeed and the country succeeds in developing indigenous HPC all over the country, installed and then exported kind of a things. I'm thankful to the team sitting on the dais, ex-DG of CDAC, present DG CDAC, and then the Sanjay for giving us opportunity this, and Mighty, encouraging us to participate in these things. Friends, yes, there are many proposals that are waiting with CDAC and then the other agencies in this country on the upcoming technologies. As Sanjay shared, Sapphire Rapids, we are already collaborated with CDAC, and then working towards generating the next generation server platform, which will sustain at least next 3 years in the market, if not later kind of a things. In the similar way, at a system level, not only processor, not only computing, but you also need to improve the IO because huge data sets are coming up. Petabytes, earlier, even a gigabytes, terabytes was a big standard storage, but petabyte per plop kind of a things that are demands coming up. How do I move that storage? There is a DIAS file system. We are already working with CDAC on DIAS file system adaptation onto the existing params and then the future params. Then Intel Arc is the brand for its GPUs. Hope to see that we collaborate with CDAC and then the ministry organizations to spread this across the country. One API is a standard. We are working across the country to develop these skills in the country, and then port these codes to be made available. Not only Intel, it should be running on NVIDIA, it should be running on AMD, it should be running on application-specific processors which are coming up in the market, including the Shakti processors when it picks up into server class kind of a processors. You don't need to develop a specific application-specific toolset usage for that. Yes, we spoke about open source performance and now the scale. There is a rigidity in every organization once it's successful. Intel also has been quite rigid that we follow vertical integration. We will only use Intel foundries and other things.
Excuse me, can we?
Yeah. So this is where the IDM 2.0 come in there. Intel is collaborating with other competitive foundries, and then we are able to announce programs collectively that we scale the HPC technologies across the globe by collaborating and then scaling out across the globe, distributed kind of a manufacturing process. So with this, I thank for this opportunity and open, when the things, when I'm down on the dais, please feel free to connect with me. I'll be more, freely able to address the things. Thank you very much.
Thank you, Mr. Sita. And now, without further delay, I would like to invite Dr. Hemant Darbari, Ex-Director General CDAC, to give us his Exascale vision of India, in which he has been very deeply involved all throughout.
First of all, thank you, MIT, and for this Azadi Ka Digital Mahotsav, which we are celebrating this week, giving me the opportunity to talk about the Exascale vision of India. I have organized a talk from the 5 points where the Exascale computing vision, why Exascale, importance of India, and what exactly are the grand challenge India has to address on, technological roadmap, and Param Shankh, which is a exascale supercomputing through harmonious innovation, and looking ahead and conclusion. So our vision is to establish dependable and secure exascale ecosystem with innovative design, disruptive technologies, and expert human resources. Our mission is to develop the hardware, like not only the server, the interconnect, but even the chip. We are listening that since morning. And this way, we will be absolutely Atmanirbhar, starting from chip to server to the interconnect. And then the storage also, as we are working now, with all the components will be indigenously developed in India and through Atmanirbhar form. And there are various opportunities for the system software design, high-end software development, and make India the global leader. And to develop solutions for grand challenge, problems, and network international level. So why Exascale? The building Exascale capability system is the key enabler for accelerating scientific discovery in the world. And there is a strong correlation between research output and availability of HPC systems. Because a lot of research cannot be done until you have the high-scale computing systems which are available. Scaling from tera to peta to exa, the computing facilities are becoming a must, because now all the Nobel Prizes which you are getting is all because of the compute side, not on the real lab side. So a lot of simulations, a lot of things have to be done, and speed becomes the key challenge, key contributor in solving these grand challenge problems. So if you see that investment in the Exascale can give a ROI of 1 to 500 as per the authentic report. Again, India, through a major initiative of NSM and microprocessor development program, which we are listening to since morning, have made significant progress towards indigenous realization of the supercomputers, be it server, high-speed networks, storage system, and HPC microprocessors. And with the Param Shank, we are trying to see that we can utilize all these components in our own designed supercomputer. And this will spawn 300 to 400 MSMEs, industries, and startups. So if you see the grand challenge problems which we have to address is the numerical weather prediction, which is the monsoon mission, the climate modeling, the material research, design of new material, new periodic table, then faster than real-time simulation in the electrical grid failure or railway network, then national security, real-time analysis of the satellite imagery, and grand challenge problems in mathematics like crypto analysis, then creating energy-efficient enzymes, and CFD. We are all very much clear that how CFD has played the role and how the supercomputing is important for that, and ab initio molecular dynamics, and there are a lot more. And this will lead towards technology supremacy in the global arena. So the converged model of HPC and AI have been applied in the grand challenge problems, and India is a major contributor in all these mega projects. Like LIGO, we are there, CERN, we are there, and we are equal partners in that in these projects. Like drug discovery, I'll talk about slightly later. Here, if you see this typical application of exascale computing is whatever is the compute power we provide. I think biology, we conduct a workshop for past 7-10 years, accelerating biology. And there we have actually come up with so many solutions which are actually state of the art. Like I'll clock here, I think Sanjay had a very little time, just 1 second I'll take to tell that this remdesivir was clocked by us as early as April 18, 2020. And that simulation was done on Param series of supercomputers. And now we have seen that remdesivir played a major role into the work which has worked on to the patients of COVID-19. Similarly, cancer, P53 simulation has also given very good results from the drug repurposing side. So all these things are a need of the hour, and can only be done if we have exascale computing systems. Similarly, this is again a typical example of weather, the weather models, and how they require a high-speed computing. Similarly, you have modeling of origin of the universe in less than 1 second. Then this is the earthquake planning and warning model for the earthquake. And just I'll take three more minutes. Maybe. Fine. So earthquake. This again is majorly the compute intensive part. We have Vachantar, which we call speech-to-speech translation system, and there this is going to be part of the national language translation mission. So all these things require a huge amount of computing, and exascale becomes a major area in which we have to work towards. Similarly, NSM, I'm just skipping because we have already heard these things, these slides we have already presented earlier. But chip becomes a very important factor, and that is what exactly we've been emphasized since morning. We have the roadmap for chip design, and what we are trying to see that how the RISC-V based architecture as well as the server class architecture comes together, and we build a HPCI converged processor. So this is again a need of the hour, and we are exploring possibility with the Intel Foundry system as well as the TSMC to take these things to the next level. So with this, Shank is the, Param Shank will be the core system which we are going to build. Shank actually standards power 18 in the Indian numerical system. And these are the jigsaw we have to solve. And each of these jigsaw puzzle is a area to work on, area of research. And these things we will try to see how we can all contribute, all the people sitting here, plus nationally, internationally, we have to compete and see how we can contribute together. These things, when put together, will form a Shank, and that will be the next supercomputer, all indigenously developed in India. This is the roadmap for the whole Exascale mission, and we are trying to achieve first Exascale system by 24-25 timeline. And this is also in line with the global initiatives which are there. So we have to have a HPC AI, silicon photonics, and quantum computing convergence, and that is what exactly is the future which is available. India will have fully capable, indigenously designed, developed, and deployed Exascale supercomputing system. India will move from service economy to the knowledge economy, where the gain and are innumerable and terms of patent, royalties, and innovation. Finally, through national and international collaboration with researchers, academia, industry, and startups, India will emerge as a leader rather than being a follower. That's what we are discussing in the morning. Thank you.
Thank you very much, sir, for a very enlightening talk. Now I think the Minister of State is already there outside, so we will end this session. Sorry, we have not been having enough time for more interactive question and answers, but we're looking forward to a very good and an interactive next session, which will be after the exhibition round of the ministers is over. So thank you very much.
So we'll just close the session with the group photograph, and thanking once again our eminent panelists, thanking all of you also for being a part of this session. As announced, the Honorable Minister of State is already there. He's just viewing in the stalls, and any time now he's going to be joining us. Our real apologies for closing this session early. Thanks. So we are not waiting for tea. Request you to remain at your respective seats. If I can request the team to please change the nameplates.
Digital India
CEO,
and e-governance. No, CEO National E-Governance Division, CEO MIGA, CEO
वो तो हो गया
and
CEO
MIGA, and MD Digital India Corporation.